Okay, you guys, I am going to show you the answers to the product and sum rules page and kind of go through a few of the little sneaky things that they've done on that page and see if you caught them. Then I will show you how to do the genetic recombination problems. So here is your product and sum rules page. You're going to see a lot of green on here because I recorded this video one time and forgot to record the sound, so now I'm having to redo it. So I'm going to use a different color this time. So I'll be using red. But the 17 and 18 we did together. 19 is fairly straightforward other than the fact that you can see here that when you get to the C's, those two combinations, there's no way they can have a fully recessive child. So that's not a percent sign. That's a 0 over 0. Because you are multiplying with a 0, you get 0 as your answer. So there's a 0 there. Okay, number 20, I think you guys could have done both of these pretty easily where you get to the 1 over 16 for both probabilities. But the fact that they've got an or here is really important because they're asking you what is the probability, so like one probability total, that they would get either that combination or that combination, and that's where this sum rule comes into play. So product is what we've been doing, multiplying the different probabilities together. But when they ask you what's the probability of getting two different options, that's where sum comes into play. And then you can see over here, I took both of those probabilities and then I added them together. So 1 over 16 plus 1 over 16, because those are my two probabilities, equals 2 over 16, and I just simplified it to 1 over 8. And I know we talked about converting all these over to percentages. I just didn't do that, I'll be honest with you. But you definitely, obviously you should convert these over to a percentage again. I just didn't have a calculator handy, so I did not do that. And then as we move down to, what you doing there, to 21 and 22, really 21, the only tricky thing here is that C and D actually had like a 4 out of 4 chance, which equals 1, so 4 over 4, which equals 1. So the probability you get here is 1/8. 22, probability I got there was 1 over 64. So again, most of those are pretty straightforward. You're just remembering to multiply when you're trying to figure out the entire set. But if it tells you the probability of getting this or this, then you need to add those two probabilities together. Okay, so then let's get down to the lovely stuff of genetic recombination problems. So genetic recombination problems, recombination, when you guys were doing your meiosis packet, is when you've got chromosomes that are next to each other, and then when they overlap and touch to form the chiasma, that they swap genetics, right? So that's what recombination is talking about. So this crossover frequency that you're seeing right here is, well, how often in their experiment did the genes, so like for the first one, did A and B cross over together? So if they crossed over together more or less frequently, that tells us how close or far they are on their chromosome, okay? This thing that we're doing here is also called gene mapping. So if my explanation is not good enough, or you feel like you need a little bit more, you can Google some gene mapping videos. There's some really good ones out there that can kind of help you guys along, okay? So when you gene map, what you're doing is you're going to draw a chromosome, and I just draw mine as like a big rectangle. Some people will try to draw more looking like a chromosome. It doesn't matter. So draw like a rectangle there. That's going to be our chromosome. And then we're trying to gene map. So we're trying to say where on this chromosome are the choices they've given us, which over here you can see is A, B, and C. Okay. Now, the thing you need to know starting off here is that a chromosome is made out of map units. That's the unit of measure for how far away genes can be, and it's totally arbitrary. It's a relative term because remember, humans have 23 chromosomes, and they kind of start as the biggest and they get smaller and smaller and smaller. So map units are relative to how large the chromosome is and this kind of thing, okay? So when we're doing this, it's kind of like a logic problem, and there's not exact sciences to it because there's not a way to actually measure. You're measuring based off of the relativity of the other genes, and I'll explain that in a second. The entire chromosome is 50 map units long. Okay, so the entire thing from this side right here to this side right here is 50. It's not 100, okay? Because I think it has something to do with the two homologous chromosomes and whatnot, but just understand that it's 50, okay? So then from there, we got 50 map units for the entire thing. We can look at these frequencies over here. I always start with the largest one, so I'm going to start with this one because it's the biggest number. So it says between A and B is 24%, or 24 map units. Now I know the whole thing is 50, so 24 is relatively half. I'm actually just going to stick these kind of right in the middle because that's just the easiest place to start. So, you know, I'm going to say A is here and B is here. And if you are not using a pencil right now, I would highly suggest you do, because this is not an exact thing. You're going to try different, ways of doing this, and you're like, oh, that doesn't work, and you have to erase, okay? So A to B, okay? And what we said was that this was 24 units wide, okay? And again, relative, so if yours looks similar, that's good. So then from there, we're going to look at our other percentages. So we have A and C and B and C. So we need to map C. It is telling us between A and C right here is 11 map units. But between B and C is 13. Now, if you will notice, what is 13 plus 11? That is 24, right? That tells me that C is between A and B. Okay, so it's not on the outside of A and B, it's going to be in the middle because it equals 24. So 13 plus 11 is 24, and I remember we already have 24 map units down here. So I'm going to draw C a little bit closer to A than it is B. So C is going to be about there. Okay, so then between A and C, I've got 11 map units. And then between B and C, I've got 13. And just to check your math, you can see that that all adds up, which means that our gene map is correct. Okay. Now be careful here because we've done it, right? So we've chromosome mapped it. Then up here, it actually asks you a question. Which two genes are most likely to be inherited together? The answer to this question is always the two closest genes that you have on your gene map. So the closest thing we have here is this distance between A and C. So A and C will be the genes most likely inherited together because they're closest. Okay. So then let's look at 24. I'm going to do 24 with you, and then I'm going to ask you to pause the video and try 25 and 26 on your own, and then you can start the video again and kind of see what I do, just so we can kind of see if you can do this on your own, okay? So 24, again, always just start with drawing your chromosome, your rectangle. Lovely. Look for your largest percentage, and you can see all of these percentages are pretty small, so we're working in a small area here, but the 11 is the biggest. 11 is not very large, but we're going to go with it. So we will do that. Okay, so that means this is C and this is S. Okay, so then from there, we're going to look at kind of other percentages. So we have an 8 here, which is our next biggest. But if you notice, if we're going to map W, that's what W, between W and S is 8. Look at what else you know about W. Okay. So they're giving us things about W right here. So they're saying W and S is 8, but C and W, which we've already mapped C, is 3. Now what do these add up to be? 11. Okay, so just like up top, that's telling us, okay, W is between C and S. Okay, so, but it's obviously quite a bit closer to C. So there's going to be my W. Okay, so then that takes care of that one, and this one. So what we have left is between C and B and S. Again, information about B, right? So this is right here and right here. Now, do you see that this is 5.5 and this is 5.5 right here? Meaning B, because this adds up to 11 again, B is exactly halfway between C and S. Okay, so trying to ignore where W is. So C and S, it's halfway between, so this is going to be B here. Okay, so then let's kind of check some work and see what map units we've got. So we know between C and S is 11. That whole thing is 11. We know between C and W is 3. And we know between B and S is 5.5. Okay. So then we have to figure out what space that leaves between B and W, because that is not a distance they've given us over here. But we know the whole thing has to equal 11. So 3 plus 5.5 is 8.5. And we need 11 total. So that leaves us, ooh, we're going to have to write kind of small. This distance here should be 2.5. Okay, and that checks out because they told us between C and B over here again is 5.5. So 3 plus 2.5 is 5.5. So all of our numbers check out, which means that's right. It's right as we can be with the numbers they've given us anyways. So then remember up here it asks you a question, which two genes are most likely to be inherited together? Look for the smallest distance between two genes. So our answer here is actually W and B, because that's 2.5 map units. Okay. Okay, so before you pause the video and try 25 and 26, I want you to look at 25 real fast, because I've already worked through these. And I think they've made an error on number 25 because I couldn't get the numbers to work otherwise. I think that W and L are actually supposed to be 30%. Okay, so go ahead and change that. And then now, I'm not you to pause the video. Work on 25 and 26. You can work with a partner if you need to, if you guys need to come talk this out. And then when you are ready to come back and check your answers, then you can do that. Okay, so let's check some answers. So for 25, again, we're starting with a beautiful rectangle. So we always start with the biggest percentage, which is our W and our L. So W and L is 30, so that's a pretty decent distance apart. So this is W, and this is L, right there. Okay, so that takes care of that. Our next distance is A and D, but I don't know anything else about D. So I'm actually going to go to A and W and A and L, because I have W and L on my thing. I'm going to try to figure out where A is. Now, if you look at these percentages for A, you can see that they equal 30, 15, and 15. So A is smack dab in the middle of W and L. So I've got that. Now let's try to figure out where D is. So D, they only give us information as far as how far away it is from A. We don't know anything about how far D is from W and L. So for this situation, and I'm going to do this in a different color so you can see what I'm talking about, we know it's 20 map units away from A. We have no idea what side of A that could be on, because we know that this map unit is 15 and this is 15. It's 30 total. But we don't know where D is. Okay, so D is either right here on this side where L is, or D is over here where W is. they didn't give us enough information for us to figure out if it's on the left side of the chromosome or the right. All we know is that it's 20 away from A. Okay, so for you guys, pick a side, whichever side. Neither of those answers is wrong. You do know that the map distance will be 5 either way on that side. So whatever answer you pick, that then pushes this answer here. So which 2 genes are most likely going to be inherited together? Well, what side did you put D on? If you put D over here, right here, then your answer is going to be L and D because they're closest together. Now, if you put D over here, then your answer is going to be W and D. And the order at which you write those 2 letters does not matter. You're talking about the same section. Okay, so there's 2 different answers there because they did not give us enough information to know exactly where D is. Either way, your numbers will check out, so you're fine. Okay, you've got 2 different choices of answers there. So if you guys were arguing in the classroom, that is exactly what just happened, okay? All right, so then let's look at 26, because this one's got more on here. Now, they give you a ton of information in this word problem about flies and Drosophila and the different traits. None of that matters to this question. I'm going to guess this was a part of another question where they then asked you things about those traits. But right now, we just need to know the crossover frequencies. So let's start with the biggest one. So we see a 24% here between A and B. So I'm going to draw, that's actually exactly as what 23 is. So, you know, can kind of go off that. So here's A, and here is B. And I'm done with that one. Okay, so then our next biggest one is 16 for F. But it looks like right here, they've given us some information about F. So between A and F is 16, between F and B is 8. Now we've got A and B already mapped. Does this equal 24%? Yes is the answer. I'm doing math in my head over here, right? So that does equal 24. So that tells us F is in the middle of A and B. So, but it is quite a bit closer to B. So there is my F. Okay, so then that means I'm not done with those 2. So then I look at what else do I know? Okay, I see up here, and I'll change colors so you guys can kind of see what I'm talking about. So I see right here, there's some information about C. There's 2 different things. It says that A and C is 8, C and D is 2, but I don't have D mapped. A and C is 8, C and D is 2, D and F is 6. We know F and B is 8. Okay, hang on. So I'm going to write an 8 here so I can remind myself. And I know that this whole thing between A and B was 24. So I'm going to see if this math checks out. So if I do, I'll show you what I'm talking about in green here. This 8, this 2, this 6 that we're trying to find. So 8 plus 2 is 10, plus 6 is 16. But also plus this 8 that we just mapped. That equals 24. Okay, so those 4 numbers equal 24 as well. So what they're trying to get us to do here is everything needs to go between A and B. Okay, so from A to C is 8. So A to C is 8, so about the same kind of distance as I got here. All right, so there's a C, and that's also 8. A and C is 8, C to D is 2, and D to F is 6. So that means we're going to put it closer to C. This is where my D will go, and then let's check our math. So between C and D is 2, between D and F is 6. And then we check our math at 8 plus 8 is 16, plus 6 is 22, plus 2 is 4. So we're 24. So those all add up to 24. So that's me checking my math to make sure that my map units are correct. And it is. It all checks out. If that didn't check out, say we were trying that and it was not right, we had too many numbers, it wasn't adding up, that means that some of these genes would actually be on the outside of A and B. But right now it's working. So That seems correct. So then which two genes are most likely to be inherited together? Well, which ones are closest? The answer is C and D, because they're 2 map units apart. Okay? So hopefully that helps you understand gene mapping a little bit. Again, if you're still struggling, you can Google, or not Google, YouTube some gene mapping videos, and you can see a lot more examples where they'll kind of talk you through it. So the plan for tomorrow, because this is all I have for you guys today, so you understand your product sum rule and your genetic recombination problems or your gene mapping problems. Tomorrow, I'm going to leave you a worksheet where you will have a few gene maps to do on your own and a few product sum rules to do on your own, just to check your work. But on top of that, I'm going to add some more kind of probability problems where you guys will have to calculate probability of different genes, because we have to start getting into multiple alleles and things like that. So we will work on that tomorrow. Hope you guys have a great day.